Good morning to one and all. My name is Dinesh. Here is the eighth topic for the subject power quality facts is the introduction to the static VAR generators. Let me know what actually these static VAR generators and furtherly let me know what are the classifications in the static VAR generators that and the work functions and the principle regarding to these generators, these type of generators. Here, at first the static var generator principle, let me know about it. The principle of the static var generator is very similar to that of the active power filter as demonstrated in the picture. When the load is generating inductive or the capacitive current, it makes the load current lagging or leading voltage. The SVG detects the phase angle difference and generates leading and lagging current into the grid. Here, which makes that of the phase angle of the current almost same as that of the voltage on the transformer side, which means the fundamental power factor is unit. Here the figure below is regarding to the static wire generator. And here when we think about this figure or else the block diagram of the SVG device, here by this we can understand how the working of this device is to be done is here when one end of the static bar generator is being connected to the transformer as which makes or which act as the input for the this device. Furtherly, the four divisions of the SVG device are nothing but those are the active current, capacitive, resistive current, inductive and resistive current, reactive and unbalanced load. Here regarding to the name of the block of the SVG diagram, the particular and perspective diagram of the feature is to be run as per the block. And let me know how the SVG works. Here and static wire generator is a power electronics which based upon the device connected in parallel with that of the load, which requires the harmonic mitigation. Here the SVG works as the controlled current source which providing any kind of current waveform in real time. Here when the load generates inductive or capacitive current, it makes load current lagging or leading the voltage. An SVG detects the phase angle difference and injects in real-time leading or lagging current into electric power system, which makes the phase angle of the current almost the same as that of the voltage, bringing fundamental power factor to the unity. Here, in this box, we can note to understand the operating mode of the SVG and the waveform at different aspects of the operating mode, and based upon the operating mode what are the remarks in particular operating mode you can see in this diagram. Here let me know at the SVG device at the operating mode of no load mode. Here a sine wave is being formed where the SVG output on current is been a uniform thing where U1 and US were being always equal and the average IS current is always zero, whereas the SVG device output is no reactive current. And same as when we think about the capacitive mode, here just like that of the sine wave, which is similar to that of no load mode, but the thing which we have to notice is the values of UI and US were to be vary in the leading current. Here, when we think about the UI, which is greater than that of the US, where these are to be in perpendicular with that of the current SVG, where the current SVG is the leading thing, the voltage and its amplitude is continuously adjustable. And same like that of the no load mode and capacitive mode, here the SVG device, another operating mode is the inductive mode, where the sine wave is being classified by these two waves and the variation is being occurred due to the classify of the sine wave, and that's how the difference of UI and US being happen. In this figure here, the UI is to be a smaller thing compared to the US, whereas the ISVG is being perpendicular to that of these two values and lagging the voltage, and its amplitude is continuously adjustable. SVG structure. Delta PQC series SVG is also modular in design, and the Delta SVG system consists of one or several SVG modules and an optional liquid crystal monitor and control panel LCM. Each SVG module is an independent reactive power compensation system, and users can change the SVG rating by adding or removing SVG modules. Here, the SVG modules and LCM panel can be embedded in Delta standard SVG cabinet or in customized cabinet, where there are usually breakers, cable terminals, and surge protection devices, which abbreviated as SPD in the SVG cabinet. The function benefits. Let me know what are the multifunction benefits on using these devices. Reactive power and the imbalance compensation is being occur excellent. Reactive compensation at high speed precise of 0.99, which is less than or equal to cos phi, and stepless bidirectional capacitor and inductance compensation. Excellent imbalance correction, both negative and zero sequences, which is seen in the past diagram, and the excellent imbalance correction, both negative and zero sequence, mitigates neutral current, wide input voltage, and the frequency range adapts to tough electrical environment. Low thermal loss, which is less than or equal to 3% of the rated SVG capacity. Efficiency is always greater than or equals to 97%, and furtherly, high stability is being seen. Infinite impedance to grid avoids harmonic resonance problem, flexible applications, modular design, embedded in standard or customized cabinet, easy installation and maintenance, easy installation for the APF module replacement and expansion, wide capacity range, 50 kV, kVAR and 350 kVAR range we can see in it for the single cabinet, up to 10 cabinets in parallel. Whereas the environmental adaptability would be 10 to 50 degrees centigrade temperature, which is compatible with the diesel generator. And at last, the typical application is being seen at here. Installation with the fast changing reactive power demand like electric and furnaces and ball mills. Highly dynamic loads where the power factor fluctuates rapidly or in big steps like cranes, sawmill machinery, welding machines, etc. Correction of a leading power factor like in data centers allowing backup generators operation, UPC systems, solar inverters and wind turbine generators, railway electrification system, trains and alarms were being applied as a part of it. And at last the conclusion of this is stated as a static wire generator is a power electronics based device which is connected in parallel with that of the load, which requires harmonic mitigation, where this switch works as a controlled current source providing any kind of current waveform in real time. That's how it works and make use of it by this SVG system. Here in this, when we think about the operating mode of the SVG system, in particular no load mode and inductive mode, it is of varying over the UI and US being seen. When we think about the ISVG, which is acting through the through the line of the UI and UC in the no load mode. When we compare with that of in inductive mode, it is somewhat varying with that of the ISVG. And it is because of the voltage lagging is being present and its amplitude is continuously adjustable in nature. And same like that of the capacitive mode, where the leading voltage is being present and else that of the amplitude is continuously adjustable. And that's how the capacitive mode is to be stated and classified with that of the no load mode. And providing of any kind of current form in real time with the static bar generator is in parallel with that of the load. Thank you.